क्लॅरिटी ना भाई लाइटिंग की क्लॅरिटी ना
Good morning, all of you. Today's guest, Dr. Svcet from Communal Advocate BG Thakre, College of Engineering, Nasik. He is Associate Professor, total experience of 25 and more. Today he is delivered session, day 4. I will request to Mr. Professor to consider. Sir. I request you, sir, please express your thought. The session will be continued.
अथर्व
Good morning, and let me introduce myself. Dr. Svcet, Associate Professor and Head of Aicte Department of Aicte Atal Fdp, KBT College of Engineering, Nasik. I would like to thanks to the organizer of this Atal Fdp of Sayadri Valley College of Engineering and Technology for giving me an opportunity to share my insights, share my knowledge with you. I think this is the 4th day of this Atal Fdp. It is started from the 15th of December. In fact, my session was there yesterday. Due to university visit, I postponed to today only. I am here to deliver, to share my experiences on the machine learning. My topic is reinforcement learning. If we talk about the machine learning is a vast area. It has the different types. As it is involved from the concept artificial intelligence. And that's why the title is given to your FDP, Machine Learning Fundamentals Building AI. So artificial intelligence means what? The concept of artificial intelligence is coined first time in around 1950 by Alan Turing. Although the father of AI is John McCarthy, because he has coined this terminology, artificial intelligence, in the Dartmouth conference, and that's why name is given to the artificial intelligence. But before 5 years, the Alan Turing was there and was thinking about, can machine think? So see, what thought was there, can machine think, and they have introduced, yes, machine can think. And that's why they proposed the Turing test to mitigate, to imitate the, whether it is a person or the machine. There is a Turing test, right? And then we can say that the godfather of AI is Geoffrey Hinton, who introduced deep learning neural networks, and that plays an important role while dealing with the large amount of the data, vast amount of the data. So these three key persons, Alan Turing, John McCarthy, and Geoffrey Hinton, they have lot of contributed to all the concept of artificial intelligence. Artificial intelligence has various domains, like it is started from that symbolic knowledge. As we know that whatever the knowledge you want to represent, they have introduced the predicate logics, propositional logics, and the knowledge is getting represented in the form of knowledge, so that machine can understand that knowledge. This is the very basic step. So nowadays you people are using ChatGPT or natural language processing, right? You just type and yes, we get the answer, right? Or reply from that system. You can easily translate the language from one to another language, Marathi to Hindi, Hindi to English, whatever it may be, right? So this is what the natural language processing. Initially, the understanding of knowledge is what only some symbolic representation. The computer or the machine understand only the symbolic representation. Nowadays, it is understanding the natural language, which is that speak by the person, humans. And natural language processing, that it has the different steps, like it has the grammar and parser to have the ability to understand it. Because unless and until it understands whatever the sentence is written or the spoken by the person, it will not be able to answer it. Right? And that's why it has the ability to understand the grammar and parser of that language, that particular sentence. Right? And that's why you can find out there are a lot of development in the natural language processing. Again, we back to the concept of artificial intelligence. Yes, it is an intelligence which is given to the machines. So we can define artificial intelligence like that. It is a program that has the ability to learn, that has the ability to reason it. Right? Reasoning capacity is nothing but what are the things which are given from it reason, it find out the reasoning. Reasoning means what? I'll just give one example. Tweety is a bird, right? Tweety is a bird, and all birds can fly. Tweety is a bird, all birds can fly. From these two facts, we can easily infer new knowledge. Tweety can fly, right? Tweety is a bird. It is a one of the facts, and all birds can fly. There is another fact. These are the two different facts. And what new knowledge will be introduced from these two facts, that is called as the reasoning. Traditional AI is nothing but the perception, reasoning, and taking the action. Perception, reasoning, and taking the action. This is, we can say, that the traditional agent. Whatever the knowledge it has to perceive it from it, and infer the new knowledge. So we have provided only the knowledge like that Tweety is a bird and all birds can fly. And from these two facts, it infers the new knowledge Tweety can fly. Right? So this is what the ability to discover the new knowledge from the given facts. This is very traditional here. Then later on, initially there is a lack of the data, but later on the information data is getting increased, and with having the amount of data, it will be processed easily, right? And from it the reasoning will be happen. So machine learning, it is nothing but, we can say that, algorithms, and it has the ability to learn from the data. It has the ability to learn from the data. So machine learning model requires the data. Without any data, machine learning algorithms will never work. Okay. You can say that we have the machine learning algorithms like naive Bayes, whatever the supervised, unsupervised machine learning algorithm. As we know that supervised machine learning and unsupervised machine learning algorithm has two different approaches. But both approaches or algorithms require the data. Without the data, it is not possible to take the decision or make a prediction, right? Or we can say that the aim or objectives of machine learning algorithms are classification, right? So sometimes we have the label data, sometimes we don't have the label data. And when we have the label data means what? Supervisor is there. This is what the input, and this will be the output. That will be the mapping in between input and output, right? This will be the mapping between input and output. When we have the label data, label class along with input, then we can take a decision. We have to use the machine learning, supervised machine learning algorithms. Why it is called supervised? Because supervisor is there and it tells you ki yes, this is input and this is output. But in another case, we don't have the output. We just have the inputs. We don't know what are the outputs for this particular input. That is called as the unlabeled data. And in that case, we use unsupervised machine learning algorithms. Right? So how it works? Yes, it will be used for the classification, clustering, right? Clustering, it is unsupervised machine learning. So how it works? It find out the patterns between the data. Whatever the data are there, it find out the patterns. Similarity index. Right? Similarity pattern that will be find out between the data. Accordingly, data will be classified. This is what unsupervised machine learning algorithms. And there is a third. The type of machine learning algorithm is that unsupervised machine learning. Unsupervised, it is nothing but the combination of supervised and unsupervised. We have some label data, we have some unlabeled data. So what we do with the help of label data, we try to give the label to the unlabeled data. Okay, that is semi-supervised machine learning algorithms. This is what the background of the AI evaluation, then machine learning. As we know that the data is not available only in the form of numericals, because machine learning algorithm understand only the numerical data, not text data, images data, videos data, right? Multimodal data, we can say that. Multimodal data means any type of data, audio data, video data, images, text, numericals. Machine learning understand only numericals. Then what will do? Yes. Now, then next evaluation is get happen, that is deep learning algorithms that came into the picture. And the deep learning algorithm that deals any type of the data. Vast amount of the data, we can say that the big data. Any data, sensor data, medical data, okay, that data will be handled by deep learning algorithms. Deep learning algorithm is evolved from the neural networks. Neural network that play the important role, okay, in the deep learning while designing the deep learning models, right? So this is what the journey of AI, ML, then deep learning. Then where it comes reinforcement learning during this scenario, that is important, right? Labeled data, supervised machine learning algorithm is there. Unlabeled data, unsupervised machine learning algorithm is there. Then, when we have to use the reinforcement learning algorithms? Anybody? From you, yes? Have you heard about this word reinforcement learning before? Yes? Okay. So, most of the times you attended the session of machine learning algorithms, everyone talk about the supervised, unsupervised data, data modeling, data visualization, but no one talk about the reinforcement learning. Reinforcement learning algorithms, when it came into the picture, when we don't have the data. When we don't have the data, right? Still it is a part of machine learning algorithms. Still it is a type of machine learning algorithms. Machine learning algorithms require the data, but reinforcement learning algorithm doesn't have the data. So when we don't have the data, then we use reinforcement learning algorithms. See, supervised and supervised machine learning algorithms have a dependency on the data, but this algorithm doesn't have dependency on the data. That's why this is the beauty of reinforcement learning algorithm. It is quite mathematical. I will not go in detail mathematically, but I will try to give the insights about these algorithms with the help of different examples. Right? These reinforcement learning algorithms can be used as okay. During this session, we will start from theory to hands-on. I hope the hands-on is not possible, but we will try to understand the reinforcement learning algorithms with the help of examples. Whatever the journey of this AI evolution, it is started from the symbolic AI to the ML, then deep learning, then reinforcement learning, and last one agentic AI. We people always talk about the AI. The students are there and they have the good feature in the agentic AI. Right? So agent AI and agentic AI, we'll see the difference between, okay, at the end of this session. Okay, that is the different part. But reinforcement learning, that is nothing but the agent. Okay, it is one of the agent. Okay, and that is a core part of this agentic AI. This is the supervised, unsupervised, and semi-supervised, the concept that we already discussed here. Yeah. In reinforcement learning algorithms, it is very simple because when we don't have the data, then how we can take a decision. This is very important. When you ask to computer, this is apple. Okay, the apple that is input is given, and the computer says no, it's mango. Okay, apple image is given, computer says it's mango. Okay, then what is wrong with this? You know that the feedback will be given to the computer. It is not a mango, it is an apple. Okay, then computer understand reinforcedly. Computer understand forcefully. 2 times, 3 times, yes, it is apple. It is apple. Okay, and when next time when we give the input as an apple, then it identified correctly it is apple. Right? How this system will work? You know that small baby is there. How actually the small baby start to identify the objects. This is ball, this is bat, this is balloon, this is toy, this is mobile. How it start to identify? Because the child doesn't have the knowledge, doesn't have the data, okay, doesn't have, that, even not in the school, okay, not read somewhere, then, because every time that, you talk about keys, this is mobile, this is balloon, okay, so it observe the things. 2 times, 3 times we told them this is balloon, okay, and when we show the different and this is balloon, then it ignores it. No, this is not a balloon, this is balloon. Right? So this is what the response is given, okay, to the child. Right? For an example, how the system will work. If the system is taking the good decision, then we can give the reward. For an example, छोटा बेबी चल नहीं सकता, अगर चलने लगा 1-2 स्टेप तो हम क्या बोलते हैं? Yes, come on, okay. And if it is able to start to walk, then we can give the reward, chocolate. Okay. अगर नहीं तो punishment. If he is doing the good thing, we will give the reward. He is doing the bad thing, we will give the punishment. Right? And based on the reward and the punishment, the system start to take the decision. Reward means what? When we give the rewards to the system understands this is a good step, this is a good action for me. Okay, if you do something good, your parent will do something reward. So you understand, no, this is a good thing. Huh? Something you do wrong thing, your parent will punish you. Then you understand, no, this is not a good thing. In the future, I will not take this action. right? So this is what the cycle of reinforcement learning working. Okay.
Yes.
So it learns by trial and error. Okay, we try it and sometimes we get the error. Okay, we try it, trial and error, we start to learning. So reinforcement learning is a type of machine learning algorithms where an agent learns to make decision by performing the actions with the help of rewards and the penalties. So whatever the action is taken, so you will give the either rewards or the penalties. If rewards is given, then it understands it is good action. If penalties is given, it is a bad action. Right? So unlike supervised learning, there is no answer key, there is no label data set, and the agent must discover the best strategy to maximize the cumulative rewards. Right? For an example, you take 10 steps, and whatever the cumulative rewards for the 10 steps, that will be your, the best policy. Right? I will give a simple example. If you want to go from Nasik to Pune, I hope there might be more than one routes are there to reach Pune. Nasik, Sangamner, Pune, Nasik, Ahmednagar, Pune, Nasik, Kalyan, Pune, whatever it may be. So different routes are there. So different steps that will be taken by the agent. Okay, and out of these 3 to 4 ways, it will find out which one is the best way. Means every time it take the steps, it will get the reward. Next step will get the reward. Next step will get the reward. And total cumulative reward will be, that the sum of total rewards will be taken. Those routes gives maximum rewards. That path is the best path. That path is the best path. So Nasik via Sangamner to Pune is the best path. Right? Because maximum rewards is given to the agent. Right? So this is what the concept of reinforcement learning. This is what the difference between supervised and reinforcement learning. Data source, label data is required. It just interact with the environment. It doesn't have any data. It just interact with the environment and learn from that whatever the action is taken. Goal is that classification in supervised learning. Here, goal is that to maximize the cumulative rewards. Feedback is done because supervisor is there, because when you use the machine learning algorithms and whatever the input is given, and it will do the whatever the prediction, and it is not correct, then immediately you will get the answer because we already have the label data set. But here, the delayed reward signal that will be used. I will tell you the concept of delay reward in the coming slides. Example is image classification, and the applications of reinforcement learning algorithms are mostly used in robotics, autonomous car vehicle, Tesla car. So in Tesla car, the autonomous vehicle, driverless car, where or in gaming, online gaming, where the reinforcement learning algorithms are implemented. Right? Reinforcement learning algorithms are used in robotics as well as in driverless car. To take, because we don't have data. See, driverless car is there, no driver, and doesn't have any information. There is uncertainty, right? Okay. From Nasik to Sangamner, we don't know how much time it will take. Average time we know that, but what will be happening because the environment will be changed, right? Sometimes accident will be there, sometimes tire will be flat, right? Due to some reason, you will reach delay, okay, or you will reach averagely, okay. So this is what the dynamic environments. When we don't know about the environment, so where the reinforcement learning algorithm is. So agent that interact with the environment. So I will tell you the concept of the environment. Right. So environment having different types: static environment, fixed environment, dynamic environment. Dynamic environment means what? The environment like car, vehicle, car movement, then pedestrian, then obstacles, then trees, right? So this is what dynamic environment. It will not be fixed because we don't know how many cars will go on that road, 10, 20, 15. It will be dynamic, right? Sorry. Sorry. So, in static environment, for an example, there is a game of chess. There is a static environment, 8 by 8 cells are there. You know that the number of cells will be fixed. It is a static environment. Dynamic environments like football game, cricket game, right? The position of player will be changed, right? Road condition will be changed. These are the type of dynamic environments. So here, the agent that interacts with the environment, why it interacts with the environment? Because it has to absorb, it has to perceive some information from the environment, right? Once the information is absorbed or perceived from the environment, it takes the decision. Okay, it takes the decision, and based on that decision, will get it the rewards, either positive reward or negative reward. Negative reward are penalty, positive rewards are that is choosing the best action. I will give the simple example. Signal, signal traffic, okay, and where signals are there, and you don't know कि अगर green हुआ तो क्या करना है या red हुआ तो क्या करना है, you don't know, right? So what will you do? You just observe the things. Sometimes there is a green signal, and you know that the cars are going on. So you observe it. अरे ये green हुआ तो कार जा रही है तो मुझे भी जाना चाहिए. अरे ये रेड हुआ तो स्टॉप है तो मुझे स्टॉप होना चाहिए. अगर वहां पे कुछ लोग नहीं है, अगर रेड है तो आप जा रहे हैं तो पुलिस ने पकड़ा, दिस इज पेनल्टी. तो वहां से लर्निंग मिलता है कि नेक्स्ट टाइम अगर रेड हो तो जाना नहीं चाहिए, अगर ग्रीन हो तो जाना चाहिए. दिस इज व्हाट लर्निंग, राइट? मशीन लर्निंग मींस व्हाट? हाउ द कंप्यूटर इज एबल टू टेक द डिसीजन, able to learn itself, right? Able to learn itself, right? So for that, here reward system is used. So positive rewards means yes, you are learning in a good way. Negative rewards, you are not learning, right? So this is what the structure or the cycle of the agent and the environment. The simple example, I already told you कि small child is there and you walk 2 steps away, so I give you a chocolate, okay, and this is what the reward, and there is an interaction with the agent and the environment, okay. For the good action, we'll get the rewards. For the bad action, we'll get the penalty. Reward in terms of positive and the negative. So now we can say that the complex part of this reinforcement learning algorithms is getting started. The different symbols are used because it's based on the equation that is called as the Bellman equation. Right, Bellman equation, it is used in dynamic programming. Those teachers are teaching design analysis algorithm, dynamic programming is there. So dynamic programming is used to take the optimal decision, greedy decision. Right? Greedy decision means what? Suppose I am here, I want to, whether I want to go this state or this state. So 3 steps are there, right? So you know that traveling salesperson problem. You students know that in discrete mathematics, TSP, traveling salesperson problem, right? So traveler has to visit each city, right? So from this position, it has 3 directions to reach 3 different cities, right? Sometimes the distance along with that cities which are given, आणि जे डिस्टन्स सर्वात कमी असतं ते पाथ आपण पहिले सिलेक्ट करतो, राईट? सो समजा x पासून x to y, z and w. X to w is minimum distance. So we will choose that minimum distance path. It is called as a greedy method, greedy approach. Means from the current position, how much distance to the next, based on that we take the decision. But that may be good or the bad. Initially, whatever the information that you have, in my point personal, I don't know the distance from source to destination. I know the distance from my state to the immediate current states. So it will if you consider, if you select the minimum distance, so it is good or bad. Right now it is good because we don't know the further distance. But आगे जाके पता चला कि अभी यहाँ से जो नेक्स्ट सिटी है वो बहुत दूर है. अगर हमने दूसरा रूट चूज किया होता तो दूसरे सिटी से ये जो डिस्टेंस है ये बहुत नजदीक है, राइट. तो पहले क्या हुआ कि हमें लगा कि ये पहले स्पॉट से 20, 30, 40 डिस्टेंस है तो हमने 20 चूज कर लिया, और लेकिन 20 से जो डेस्टिनेशन है वो 50 है तो टोटल 70 बन गया. अगर स्टार्टिंग में 30 चूज किया होता तो नेक्स्ट से 10 किलोमीटर का है तो 40 किलोमीटर का डिस्टेंस है. तो पहला पाथ जो चूज किया हमने रॉन्ग किया, राइट. रॉन्ग किया ना, क्योंकि पहले टाइम हमने वो 20 लेस था इसलिए सिलेक्ट किया, लेकिन उस सिटी से आगे का जो डिस्टेंस वो ज्यादा है. लेकिन अगर वो 50 वाला चूज करते तो आगे से 10 किलोमीटर का है तो 60. सो टोटल क्यूमुलेटिव रिवॉर्ड्स. सो माय फर्स्ट दे यू नो दैट द कीवर्ड्स वाज देयर कि you have to that maximize the cumulative rewards, total rewards, not the current. That's why in order to solve such a problems, the concept is introduced MDP, Markov decision process. Markov decision process. It deal with the Markov property. The Markov property म्हणजे काय हे मी तुम्हाला एकदम सोप्या भाषेत सांगतो. Markov decision process म्हणजे Markov property आहे. Andrew Markov, who is the mathematician, he has developed this the concept, right? Markov property. Markov property take the decision based on the current state only, present state. आपली जी प्रेझेंट स्टेट आहे त्याच्यावरच डिसिजन घेतो. मशीन लर्निंग अल्गोरिदम मध्ये काय होतं, हिस्टॉरिकल डेटा दिला जातो आणि बेस्ड ऑन दॅट हिस्टॉरिकल डेटा इट टेक द डिसिजन. बट इन रिइन्फोर्समेंट लर्निंग इट यूज द मार्कोव डिसिजन problem or the property, it take the decision based on the current state only. But condition is that the conditions is that the previous state, what are the old states or the current state, the selection of the next state should be that based on the present state only, not past states. Simple example let me. Today is a cloudy. For an example, today is a cloudy. So what would be the weather tomorrow? Today is a cloudy. What would be the weather of tomorrow? Right. So prediction or decision is based on the today's weather, not yesterday, day after, day before yesterday. Right. मागच्या 8 दिवसात पाऊस होता की ऊन होतं त्याच्यावरती उद्या काय असेल हा डिसिजन नाही घ्यायचा. आज काय आहे त्याच्यावरती उद्याचा डिसिजन काय. दॅट इज मार्कोव प्रॉपर्टी, राइट. टुडे इज सनी, सो व्हाट विल बी द नेक्स्ट. सो दिस इज ऑल अबाउट द प्रोबॅबिलिटी, राइट, or state transition probability, we can say that. All these information that from present state to the next state of itself, right. So that is called as the state transition probability. We define our problem in the form of state transition probability. And based on the probability, we will decide what would be the tomorrow, whether it is sunny or cloudy or rainy, right. So tomorrow's decision based on today's decision, not yesterday or day before yesterday's decision. Understand? Okay. So another example here I take here, and this is we can say that the brain warming session. Self-driving car, right. In the self-driving car, the agent means who is agent in self-driving car. Yes, anyone is there? Software, AI software, right. AI software is used in a car, that is the agent. Who is going to take a decision? Software. the AI program is implemented in a car, so it will take a decision. So agent is going to interact with the environment. So environment, what comes in the environment with respect to this self-driving car? Environment मध्ये काय येऊ शकतं? Obstacles. Then how many vehicles are, you know that, running on the lane, first lane, second lane, right? Signals, right? This is what the environment. State means what? Cars current speed, current position, vehicles current speed, vehicles position. This is what the state. This is what state. Right, 80 km per hour, this is state. 60 km per hour, this is state. 20 km from Nasik, this is state. These are the different states. Right? Action, yes. Action, it has to take the action based on whatever the information perceived from the environment. If there is an obstacle, then action is to avoid the obstacle. Car will avoid the obstacle. This is action. Right? How we can take the action? With the help of actuators. And actuators, you know that key, steering, right? Moving steering, accelerator, braking. These are the action points, na? Okay. If you have to increase the speed of vehicle, acceleration. Right? If you want to stop the car, braking is there. If you want to move the car to the left, that is steering, right? You know that this is what the action. Whether you want to move to the left or the right or avoid the obstacle, hit the obstacle, right? The car is able to avoid the obstacle, will get the reward. If car hit the obstacle, get the punishment or the negative rewards. See, rewards, right? Positive rewards means car safely avoid the obstacles. Car hit the obstacles, getting the negative rewards. And policy, it is very important key terminology here. It is a strategy, like you know that takes the action, okay, from one state to another state. Like the car should, you know that, move the steering left while approaching curve. Right? Because environment is getting changed. जर कर्व आला, रोडला असा कर्व आला, तर तुमची जी काही स्टेअरिंग असेल, ती स्टेअरिंग विल लेफ्ट साइडला थोडी मूव्ह झाली पाहिजे. जर राइट साइडला कर्व आला, तर राइट साइडला मूव्ह झाली पाहिजे. So these are the actions. Moving left, moving right, these are the actions. Right? But the taking a action is nothing but policy. म्हणजे ह्या स्टेटला, स्टेट काय आहे तुमची? आता कार ह्या पोझिशनला आहे आणि तुमचा समोरचं जे काही एन्व्हायरमेंट आहे तिथून असं इन्फॉर्मेशन परसीव केले की समोर कर्व आहे, टर्न आहे, तर लेफ्टला आता तुम्हाला कार लेफ्टला जी काही तुमचं स्टेअरिंग आहे ते लेफ्टला घेतलं पाहिजे. दिस इज व्हॉट द ऍक्शन, राईट? अँड दॅट इज कॉल्ड एज द पॉलिसी. पॉलिसी मीन्स मॅपिंग स्टेट टू ऍक्शन. वॉट एव्हर द स्टेट इज देअर अँड वॉट एव्हर द ऍक्शन इज टेकन अंडर दिस पॉलिसी, okay, with respect to the state. That is state action mapping. It is called as the policy. Right. Now, there is a dilemma of exploration and exploitation. Right. Because we don't have any knowledge, any data to train the model. So what we do? Initially we randomly take the action. Randomly take the action. Right. 1, 2, 3, 4. Because if you you know that explore only one action and whatever the reward is getting, sometimes you will miss the best action. जर तुम्ही एकच ऍक्शन घेतली आणि एकच ऍक्शन फॉलो केली तर तुम्ही बेस्ट ऍक्शन मिस कराल. म्हणजे कसं, तुम्हाला जर समजा आळे फाट्यापासून ह्या कॉलेजला यायचं असेल आणि 2 ते 3 रूट असेल आणि तुम्ही एकच रूट फॉलो करत असेल, सेम ऍक्शन घेत असेल, तर यू विल मिस द अदर रूट विच इज द बेस्ट वन. Okay, exploration means what? Explore the new knowledge, new route, this route, this route, this route, this route, right? And out of this route, make it best one. that is exploitation. Exploration means explore the new routes, and exploitation means find out the best one. आलं लक्षात? म्हणजे हे 3 रूट आहे, या 3 रूट पैकी ही बेस्ट आहे. Action A1, A2, A3. There are 3 actions I can take, but taking action A1 is the best one, that is exploitation. Right? मग तुम्ही जर सुरुवातीलाच एक्सप्लॉयटेशन केलं की हीच ऍक्शन बेस्ट आहे, तर यू विल मिस द अनदर बेस्ट ऍक्शन. सो ट्राय टू एक्सप्लोर युअरसेल्फ. जसं बरेचसे मुलं आहेत त्यांना सांगतो मी, दे विल व्हेरी सून जॉइन द कंपनी and they will feel that this is the best job for me, I will remain stay here, right? This is the best job for me. तुम्ही जर दुसरे जॉबच एक्सप्लोर केले नाही, then how you can distinguish, how you can get the knowledge of other jobs which are the best. आलं लक्षात? तुम्ही एकच जॉब घेऊन बसला तर तुम्हाला बाकीचे जॉब कळणारच नाही. तुम्ही 5 जॉब जर फिरून आला तर 5 पैकी यू कॅन मेक अ चॉईस, यू कॅन मेक a decision that this job is the best for me. This is what the exploitation. Exploration means just explore all the jobs. This is exploration. And find out the best, which one is the best job? Exploitation. Right? So exploration and exploitation. So to make a balance between it is very important. And तुम्ही म्हणाल की सर एक्सप्लोरेशनच करत बसू, दर 5 महिन्याला स्विचिंग, IT इंडस्ट्री दर 10 महिन्याला 1 वर्षाला स्विचिंग, 10 वर्षाला वीज जॉब, एक्सप्लोरेशन, त्याला कळलंच नाही बेस्ट कुठला आहे. राईट? आणि सुरुवातीला 2च जॉब बघितले, दोन्हीमध्ये डिसिजन घेतलं दिस इज द बेस्ट. राईट? सो दॅट इज ऑल्सो नॉट अ गुड. इनिशियली ओनली द एक्सप्लोरेशन, इट इज ऑल्सो नॉट गुड. Very soon make a exploitation, it is not a good. So make a balance between exploration and exploitation. That is what the dilemma. क्या करना है मुझे, एक्सप्लोर करना है कि एक्सप्लॉइट करना है, एक्सप्लोर करना है कि एक्सप्लॉइट करना है, ये जो डायलेमा है ना. So where this, you know that the solution is that epsilon greedy solution. So what is the solution for this dilemma? Epsilon greedy solution. Next. So how it works, epsilon greedy, you know that. So there is one algorithm, okay. So very simple algorithm is there. We can start to exploration, and you know that there is a epsilon. Epsilon is a mathematical terminology, and you will define the value for the epsilon. That is 0.2. 0.2 म्हणजे मला 20% एक्सप्लोर करायचं आहे. 0.8 म्हणजे मला 80% एक्सप्लोर करायचं आहे. Right? If you set epsilon is equal to 0.2, it means that in between 0 to 20% you can explore yourself and find out the best one. Okay? If you put epsilon is equal to 0.5, 0 ते 50% मध्ये मला एक्सप्लोर करायचं आहे, and you will find the best one. So any random number will be generated if this random number is less than whatever the epsilon value is taken. If that random number is less than that epsilon values, then exploration करायचा. Otherwise exploit. म्हणजे choose the best action. Okay, जर तो random number त्या epsilon value पेक्षा जर लहान असेल तर फक्त ऍक्शन तुम्ही शोधत राहा, एक्सप्लोर करत राहा. डोंट मेक अ फायनल डिसिजन. ओके? आणि जर तो रँडम नंबर त्या epsilon व्हॅल्यू पेक्षा जास्त आला, मोठा आला, तर त्यावेळेस तुम्ही ज्या ऍक्शन एक्सप्लोर केलेले आहे त्याच्यातनं डिसाइड करा की आता which one is the best. You got it, partner? This is what epsilon greedy algorithms. It is used to make a balance between exploration and exploitation. Okay, so I'll give the example, real-time examples on this. See, you people are, use the social media, YouTube's, Netflix, right? What are the contents you watch? So next time it recommend you the same. Whatever the products that you search, they are, that on Amazon, Google, so Amazon will recommend these products or advertise, it will show the advertise regarding that products to you, right? how it happens. Right? See the concept. Whatever you like, whatever you click the things, so based on that it will show the advertise to you. Initially, exploration. Initially, it will show the random any advertise to you, randomly. But after some experiences, after some time, काही वेळानंतर you will find out that you will get the ad or the ad will be displayed to you only what you want. Only what you want. That is called as exploitation. सुरुवातीला तुम्हाला वेगळे ऍड दाखवत गेले आणि ते 4 ऍड दाखवले, 4 ऍड पैकी तुम्ही एकाच ऍड वरती जास्त फोकस केलं. Again you click on that ad. Okay, so they assume that means based on this mathematical equation कि it will give the maximum rewards whatever you like most, whatever you click on most. Okay, so it will calculate the maximum rewards for that particular ad, and those ads will get maximum reward. That ad will be displayed to you. So initially 3-4 ads randomly you get it. But from your actions, what action you take? Sometimes you get one ad, you ignore it. Second, sometimes you click once. Third ad, you click twice, you like it. Okay, so they understand. Now this advertise, you are interested in this advertise. So next time only that advertise will be displayed to you. Right? So this is what the exploration and the exploitation that is used here. This is the real time examples we consider. There are many applications of this exploration and exploitation of the greedy strategy in reinforcement learning algorithms. The dynamic ad pricing. This is very important. Key ad shows, because from that ad they get the revenues. So which ad getting that which ad will be visited by more. Okay, and based on that pricing will be done. There is evening show. So for the evening show, there is that the advertising rate is higher for the evening shows because users will watch that evening show. Okay, in large amount, right? Then real time bidding, then content recommendation in Netflix, YouTube's where it is used, and email campaign. What type of the email you want to write or what contents you want to suggest to the user, and accordingly user like it. So next time it will suggest only that contents. Even ChatGPT, what ChatGPT that do the same thing. Okay, whatever you ask the question to the ChatGPT will reply you. Okay, and it will ask you, do you like it? Yes. If you get it, if you like it, or you accept it as it is, okay, and without giving any the another query कि नहीं मुझे ये नहीं चाहिए, मुझे ऐसा चाहिए, ऐसा चाहिए, ऐसा चाहिए. So accordingly, that it gives the rewards for that particular queries, and next time you will get the perfect contents. Initially it will get you some random contents, but it will take the feedback from yourself. See how reinforcement learning algorithm is generating the data from user itself. Right? Initially it will show you random products. Okay? Because they don't know what you like. Okay? I don't know what you like. The system doesn't know what you like. Sometimes you watch this some contents, okay, on Netflix, and then they will suggest कि these contents you will be like, right? तो अगर आपने वो भी content देख लिए, तो वो he start giving the rewards to you, okay? And next time you will get the only that contents, okay, not random contents. So this is what the strategy, or it is called as the policies. Okay, कि आप क्या एक्शन लेते हैं, आपकी स्टेट क्या है. इनिशियली आपकी स्टेट आपको पता नहीं रहती, राइट? तो सिस्टम जनरेट द रैंडमली थिंग्स, ओके, एंड व्हाट यू क्लिक, लाइक, वॉच, बेस्ड ऑन दैट इट गिव द रिवॉर्ड एंड मेक अ पॉलिसी. सो नेक्स्ट टाइम you know that it makes the perfect policy for you, and finding the best policy, it is the main objective of reinforcement learning algorithms, right? There are many the types of machine learning reinforcement learning algorithms. I'll just cover only one or two algorithms, okay? because it is not possible to cover all these things. This is a complete course. We can say that reinforcement learning. Basically, it has two types: model-free reinforcement learning and model-based reinforcement learning. What is the difference between model-free? It doesn't have any model. For example, autonomous vehicle कि आप कंप्लीट प्लान नहीं दे सकते ऑटोनोमस कार को कि ये मेरा प्लान है, इसके हिसाब से जाओ। आगे जाके कुछ भी हो सकता है, एक्सीडेंट हो सकता है, कार ज़्यादा हो सकती है, ट्रैफिक जाम हो सकती है, टायर फैट हो सकता है, कार बंद पड़ सकती है। Lot of things are there, lot of uncertainty is there. That's why you cannot give the model कि इसके हिसाब से चलो. That is model-free reinforcement learning. In some case, you can give the model. Okay, कि इस हिसाब से आप खेलो, you will get the success. Model based learning. Some model will be provided and it will follow the model and accordingly try to get the that maximum reward. So this is what the model based and model free reinforcement learning. So model based dynamic programming is there, model based, but lot of that due to the dynamicity in the environments, the people never use the model based, it always use the model free reinforcement learning because it is a dynamic. My PhD topic was there, reinforcement learning. I just recap that within 2 minutes my PhD thesis, reinforcement learning. Actually, some maybe the people from the electronics background, cognitive radio networks, it is one of the emerging area. In cognitive radio networks, what happens? There is a dynamic channel selection methodology. You know that there is a Wi-Fi access point, and Wi-Fi access point has different channels, right? So, selection of channel, which channel is the best to send the traffic? That is what selection of channel. This is the action. How we can choose the action which will select the best channel for me to transfer the data. Right. So I have used reinforcement learning algorithms because initially I don't have the data कि ये channel अच्छा डेटा रेट से डेटा सेंड करता है, ये चैनल बिजी रहता है, ये चैनल फ्री रहता है, ये चैनल 12 बजे के टाइम पे बहुत ट्रैफिक रहता है इस चैनल पे, ये चैनल पे शाम को 6 बजे बहुत ट्रैफिक रहता है, ये चैनल always free रहता है. Okay, I don't have any type of knowledge. So what I do, I will start the exploration. First time I will start to use channel number 1 and send the data. I will take the feedback from it कि ये मेरा डेटा कितने टाइम पे पहुंच रहा है, कुछ लॉस्ट हुआ है कि नहीं, पैकेट लॉस्ट हुए कि नहीं, एरर फ्री डेटा पहुंचा है कि नहीं, कितने टाइम में पहुंचा. नेक्स्ट टाइम मैंने सेकंड चैनल यूज किया, नेक्स्ट टाइम थर्ड चैनल यूज किया, फोर्थ चैनल यूज किया. पहले मैंने एक्सप्लोर किया, बाद में आई स्टार्टेड टू एक्सप्लॉइट इट कि ये 5, 6, 10 चैनल यूज करने के बाद मुझे पता चला कि नाउ आई कैन यूज चैनल नंबर 7, इट इज द बेस्ट फॉर मी. Right. So this is what the reinforcement learning algorithms I have used to select the channel for routing to transfer the data. Model based and model free. In model free reinforcement learning, there are again 2 types: value based and policy based. Policy based means policy is already given and it tries to find out the optimal policy, okay, or try to improve the given policy. That is on policy. In out policy is not given. It improve the policy irrespective of whether the policy is given or not. That is out policy. Okay. So it is a value based, means for each state it gives the some value. For example, I am here, it is the first state and I want to go there, it is another state. Whether I want to go this side or this side. These are the 3 different states. I am here at present state, I want to go to the 3 state. So which state I will choose it? Suppose I choose the first action, okay, then second, then third. If I choose the first one, I will get some value. That value is nothing but that state value. If I go from first to third state, so the value will be returned to the third state. I go from 1 to 4th state, the value will be returned to the 4th state. So value is returned to the each state, and those state is having the maximum values, that state will be the best state to move ahead. Right? So this is what the value based. Here only the state values is considered, but there is another type, the action value is also considered. So state action values is considered, it is called as the Q value, quality values. जिथं स्टेटची व्हॅल्यू आणि ऍक्शन, स्टेट आणि ऍक्शनची जी व्हॅल्यू घेतली जाते त्याला क्यू व्हॅल्यू म्हणतात. आणि दोज स्टेट ऍक्शन व्हॅल्यूज हॅव्हिंग द बेस्ट क्यू व्हॅल्यूज that will be considered the best action. So based on the Q value, it will choose the next state. Okay, थोड़ा सा complicated है, mathematical है, but try to understand it. Actor critic, it is another type of reinforcement learning where actor means agent. Actor means agent. Actor interact with the environment. Okay, it takes the action and get the feedback from the, you know that there is a supervisor, we can say that, and it tells to the actor whether the action, the chosen action is good or bad. जी action मी घेतली ती good आहे की bad आहे हे सांगण्याचं काम कोण करतं? Criticize is another program. There is no any human. Actor is a one agent, critic is also another agent. Actor choose one action, then critical is there or criticize that action, if this action is not what you should choose this action. That is what another agent will tell you. Multi-agent programming. In SCI, human computer interface, you know that agent interact with the human. We interact with the website, okay, we interact with the chat GPT, where human involvement is there. But sometimes there is no human involvement. For example, there is a online chess game, it will be played one computer with the another computer. Who will win? If you play with computer, then who will win? Right? Because there are two players, one is human, another is machine. But in another case, both are machine. They are playing the cricket. They are playing the chess game. Who will win? Okay, so this is multi-agent concept. So here critic is another agent, will tell you to the actor what are the action that were taken, is it good or bad, okay, or what you do. Okay, so that is criticize. Yes, reward, with the help of rewards we can give the values to that particular states. Markov decision process, right? I'll tell you one concept here. हे जे rewards आहे, हे rewards calculate कसे करायचे, right? Because reward action घेतल्यानंतर reward मिळणार, then how we can calculate the rewards, total cumulative rewards. There are two types of the task, episodic and continuous, right? Episodic task means what? This task is having start state and goal state, right? Initial state and the goal state. Means what? Ki there is a, you know that there is a task which is having the end. हा जो सेशन आहे, या सेशनला एंड आहे episodic task. There is a break and again next session will be start and there will be it. जर या सेशनला एंड नसतं तर कदाचित तुम्ही बसले नसते. स्टुडंटची चोळबुळ चालू झाली. जर समजा हा कंटिन्यूअस असतं की हा सेशन कंटिन्यू चालू आहे, तर तुम्हाला माहिती आहे हा सेशन कधी ना कधी एंड होणारच आहे, 1 तासाने, अर्धा तासाने, राईट? दिस इज एपिसोडिक टास्क. And from the first point, from the first second to the end of session, what you gain it, that is reward, total reward. प्रत्येक मिनिटाला तुम्ही काय अचीव केलं त्याचे रिवॉर्ड्स ऍड करत चालायचे आणि टोटल रिवॉर्ड विल बी एपिसोडिक. ठीक, दिस इज एपिसोडिक टास्क. Another is a continuous task where there is no end, right? इथला गोल स्टेट नाहीये. फॉर एक्झाम्पल चेस खेळायला बसतात तुम्ही, एक तर चेस ड्रॉ होऊ शकतो, तुम्ही जिंकू शकता किंवा समोरचं जिंकू शकता, त्याला एंड आहे. 20-20 मॅच आहे, एक तर ओव्हर संपतील किंवा सर्व प्लेयर आउट होतील, बरोबर? किंवा मॅच ड्रॉ होईल, बरोबर. एपिसोडिक एंड आहे. कंटिन्युअस मीन्स व्हॉट? फॉर एन एक्झाम्पल की द कंटिन्युअस, देर इज अ कंटिन्युअस इंटरॅक्शन विथ द एन्व्हायरमेंट्स. फॉर एन एक्झाम्पल, in stock market, agent will tell you whether you want to buy or sell the shares. It is continuously working on it. There is no end की नहीं आता हा जो stock market आहे ते end होईल. It is continuous process. It continuously interact with the environments based on the present states. It tell to you कि whether you want to buy or sell it. That is what continuous. So in that case, the rewards will not be calculated or will not be summed up. Instead of, the gamma is introduced. Gamma is a discount factor. Okay. So what is use of the discount factor? जर तुम्ही आत्ताच सुरुवातीचे जे रिवॉर्ड्स आहे त्याच्यावरती सॅटिस्फाईड झाले, कदाचित तुम्ही फ्युचर एक्सप्लोर नाही करू शकणार. कदाचित तुम्हाला फ्युचर मध्ये गेल्यानंतर अजून चांगले रिवॉर्ड्स मिळतील. राइट. म्हणून द गॅमा इज इंट्रोड्यूस्ड की यू एक्सप्लोर yourself, okay, explore the different actions and gain the rewards, delay rewards, future rewards. म्हणजे काय, आता जे रिवॉर्ड मिळणार आहे 2 वर्षांनी जे रिवॉर्ड्स मिळणार आहे, सो यू वेट फॉर द रिवॉर्ड्स विच आर गेटिंग आफ्टर 2 years. राइट. जसं आज तुम्हाला एक 20,000चा समजा मुलांना जॉब लागला आणि त्यांच्याकडे समजा एज्युकेशन एक ऑप्शन आहे आणि 20,000चा एक जॉब आहे, तर व्हॉट दे वांट टू डू? एज्युकेशन करायचं 2 वर्ष की जॉब करायचा? राईट. पण 2 वर्षानंतर कदाचित एज्युकेशन केल्यानंतर जास्त पैसे मिळू शकतात, बरोबर आहे की नाही? सो फ्युचर रिवॉर्ड्स, the value of future rewards will be same as the today's rewards, but you should consider the future rewards so that you can get the best action. That's why gamma is introduced here, and the formula is there. There are 2 formula in both. Reward is equal to reward for the next state, then rt plus 1. For example, at a time t reward, at a time t plus 1, t plus 2, t plus 3. So next step ला, प्रत्येक स्टेपला काय तुम्हाला रिवॉर्ड्स मिळतील. त्याची सरळ टोटल करणं म्हणजे तुमचं जिथं एंड असेल, गोल स्टेट असेल, तिथं तो फॉर्म्युला यूज करायचा. अदरवाइज इफ यू वांट टू यूज द फ्युचर रिवॉर्ड, continuous task like vehicle, autonomous vehicle, continuous task, there is no end because you don't know, okay, what happen next. So then you can use this formula, that is reward is equal to summation of k is equal to 0 to infinity gamma raised to k rt plus 1 plus 1. This is the formula to calculate the rewards. Okay, थोडासा mathematics reinforcement learning मध्ये, but if you understand how to calculate the reward for my actions, then you can understand what type of the environment is there according to the formula that you want to choose. So what the values you can take of this gamma. So optimal values, it is in between 0.2 to 0.8. If we put the gamma is close to 0, okay, then it is short-sighted. Short-sighted means what? It just give the importance to the immediate rewards. मी एक ऍक्शन केल्यानंतर जे रिवॉर्ड मला मिळाले त्याच्यातच मी खूप खुश आहे, त्यालाच खूप मी महत्त्व देतो. Then you put gamma is equal to 0.1, 0.2, 0.123. If gamma is close to 1, like 0.9, then I will think about the future, not immediate. मला भविष्यात काय मिळणार आहे त्याचा विचार करतोय मी. सो डिलेड रिवॉर्ड्स, राइट. सो द गॅमा व्हॅल्यू शुड बी 0.9, so that we can find out the bestest of best action in the future. I will not satisfied with the local actions. की जे आता माझ्याकडे जे ऑप्शन्स अवेलेबल त्याला मी सॅटिस्फाईड नाही होत. I want to satisfied in the future, and that's why you put 0.9 so that it will explore and try to maximize the rewards. there, and based on the Q values, you can find out the best action. This is again, we can say that. Yeah, just look at this game and what is there, you just find out. Just let me know what is happening there. Yes, anybody want to describe this? The description is already there on the slide. काय गेम आहे हा? This is a game of the frozen lake. Frozen lake is the environment. Environment is nothing but the simulation. It is created. If you Google gym environment, open here, gym environment, you will find out frozen lake. It is one of them. So in this environment, you will find out that the person is there, Pac-Man is there, and he has to reach to the goal state. The goal state which are given at the bottom, right bottom corner. Gift is there. He has to reach there. There are some frozen cells. This Pac-Man can go over the frozen cells, but there are some hole. Okay, if the Pac-Man goes to that particular cell which is having hole, then he will kill. Okay, or game will be quit. So his objective is that avoid the whole cells. Avoid the whole cells and move over the frozen cells and try to reach to the goal state. Right? So he has to decide whether I want to move left side, right side, up or down. So he has 4 actions. मला लेफ्ट ला जायचं, राइट ला जायचं, अप जायचं की डाउन ला जायचं. He has 4 actions, and out of these 4 actions, he has to choose the only one action, because he can perform only one action at a time. If he choose left, then some rewards will get it. He choose right, some rewards will get it. He choose up, some rewards will get it. He choose down, some rewards will get it. Then it will decide which action got the maximum reward, and that action will be chosen as a best action in order to go to the next state. This is what the simple description, right? Another example I want to give here, demo environment card board. Okay. How many students or faculties from mechanical department, mechanical background? Okay. They know that this is what the card board, right? There is a one card and the pole. Our aim objective is that to balance the pole, right? To balance the pole. So what will be the state, action, reward and policy for this card pole environment? Now the pole is shifted towards the right? So we want to move card towards the right, so that pole will become straight, right? So card's position we want to there, whether the card position we want to move towards the left or the right, based on the position of the pole. So position of card is nothing but the state. Position of the pole is nothing but the state. And based on that, the states, he has to take the action whether he has to move left or the right. Action only choose left or right. States position itself of card, position of pole itself is a state. The position of card is measured in terms of distance, but position of pole is measured in terms of angle, right? Angle, okay, 30 degree, 20 degree, 40 degree. And accordingly, we want to move the card so that we can balance the pole straight. So we define the different states. Here card position is one of the state. Then card's velocity is another state. Velocity means how much force you want to apply to the card. This is what card's velocity. कि फोर्स म्हणजे किती स्पीडने किंवा किती फोर्सने आपल्याला ते कार्ड मूव करायची आहे. ओके. देन थीटा इज अ पोल पोझिशन की पोलचा अँगल काय आहे. And theta underscore dot is a pole tip velocity कि how much की velocity of the force we want to apply to the pole so that pole can become straight. Right. So this is what the state. And state space we can define the values for all those four states. Here range of values which are specified minus 2.4, because see from 0 to left side there is a negative values, from 0 to right side there are positive values. From 0 to left side negative values, so total distance is minus 2.4 and for the right side plus 2.4. So it is in between. Because position of card that will be take place in between minus 2.4 to plus 2.4. Beyond this position, game will quit. Okay? Beyond this position, it will not work. So we define it. Angle, it is given in radian, minus 41.8. It is I think 24 degree. If you convert it to the degree, it is a 24 degree. So angles maximum length, maximum angle is given minus 24 degree to plus 24 degree, but it is represented in the form of radian. Theta to radian conversion is there. And here card's velocity and pole tip velocity that we don't know. कि हमें कितना फोर्स अप्लाई करना है ये हमें पता नहीं है, कितना करना है. So where we can initially the range we define infinity, minus infinity to plus infinity. You know that volleyball is there. कि तुम्हाला तुमचा जो काही व्हॉलीबॉल आहे तो किती फोर्सने तुम्हाला फोर्स अप्लाय करायचा आहे की जेणेकरून त्याला तेवढी हाईट मिळेल आणि ते आपल्याला खाली येईल. राईट. सो दिस इज रँडमनेस. राईट. की सुरुवातीला तुम्ही कमी फोर्स कराल, नंतर थोडंसं जास्त, कधी कधी खूपच जास्त होईल. सो यू ट्राय टू मेक इट बॅलन्स. राईट. Reinforcement learning algorithm is also working the same way. Right. So there is a discrete structure, discrete definition, discrete values. We don't know how much force will be there, because it will be varied based on the position of pole and position of card. Every time the force will be applied differently so that it becomes state based on the state position of pole and card. Right? We don't know. So reinforcement learning algorithm will learn from the states, and then at one day it will train and do the same thing. Okay. Moving left 0, moving right 1. These are the two actions will be taken. And reward means what? Reward of plus 1 every step when it keeps theta is less than equal to 12 degree. Here one condition we can give कि जो थीटा जो पोलचा अँगल आहे तो लेस दॅन 12 डिग्री असेल तर प्लस 1 रिवॉर्ड द्यायचा. तो 12 डिग्रीच्या पुढे गेला की निगेटिव्ह रिवॉर्ड द्यायचा. ओके. सो व्हेन द पोल द अँगल इज लेस दॅन इक्वल टू 12 डिग्री देन वी कॅन गिव द रिवॉर्ड प्लस 1, अदरवाइज माइनस 1. And when running averages values of rewards is greater than 1, When this game will be quit, there are many conditions the game will be quit. Okay. If it complete the 200 steps, if it complete 195 steps, or episode ends, that is 200 steps which are given, you will get only 200 chance. You just use the 200 chance, and after 200 the game will be quit. Right? When theta is greater than equal to 12 degree, 12 degree पेक्षा theta जर जास्त गेला, पोलचा अँगल जास्त गेला तर game will be quit. X greater than is equal to 22.4, the 2.4 पेक्षा जास्त distance cross केलं पोलने, कार्डने, तर it will be quit. And दोनशे steps पोहोचल्यानंतर automatically will quit. Right? So balance pole for at least 200 steps. So this is episodic task because this task is having end state. This task is having goal state, and that's why it will be terminated, and that's why it is episodic task. Policy is what? If pole is left of the center, then move card left. If pole is right of the center, then move the card right. This is simple policies. Right. So you can see here, this is a continuous state space. State variable change continuously over the time. Okay. So take the state variable minus 2.4 to 2.4, but it is continuous. It is finite but continuous because initially we defined infinity, okay, for the force, but displacement that we have defined finite, minus 2.4 to 2.4. If you divide this into the 10 chains, this is first, second, third, minus 2.4 to 2.4, right? If you divide speed into the 10 buckets, then the size of this bucket is, you know that minus 2.4 to 2.4, it is 4.8. 4.8 divided by 10, it will be equal to 0.48. So one cell become of 0.48. 0.48. So any values of x which is indicated here, it is in between minus 2.4 and minus 1.92. How it is? Because each chunk is 0.48 and 0.48 minus 2.4 will give you minus 1.92. So x values, one chain it is in between minus 2.4 and minus 1.92 will lie in bucket 1, which is shown in red color. This is one bucket, second bucket. Second bucket minus 1.92, okay, plus 0.48 ऐड कर दो. Next जो पहले है कि 0.48 ऐड कर दो तो 10 bucket बन जाएंगे. So this is input, this is output. And this is all the formula which is already we have discussed. Reward, if it is episodic task, calculate the rewards. State way. If it is continuous task, consider the gamma discount factor and use the formula to calculate the total rewards. Here, for each state, the value will be given. For example, it gives a policy. Policy means what? Policy is given कि left side असेल तर left side ला card move करायचा, right side असेल तर right side ला angle वगैरे सर्व दिलेलं. This is what the policy. Under this policy, it tells you which state is the best. This is what the algorithms just I already told you. This is the formula to calculate the state values. State values of the next state will be equal to state values of the current state plus alpha into total rewards minus value of the current state. Here one hyperparameter is introduced, that is alpha. It's called as the learning rate. Right? Learning rate, it has the values in between 0 to 1. You have to take the values in between 0 to 1. What is role of learning rate? It is very important. It tells you कि how much data you want to overwrite by the new data. If the value of alpha is close to 0, like 0.1, 0.2, it means that it is a slow learner. If it is a slow learner means sometimes it will miss the new information, updated information. Slow learner. It will take the time to learn. It is a slow learner. If the value of alpha is close to 1 like 0.9, 0.8, it is a fast learner. It will have the information, updated information, but it is unstable sometimes. Slow learner, it is stable but miss the updated information. So it will be stuck in local maxima. तो स्लो लर्नर असेल कदाचित त्याला वाटेल की ही जी ऍक्शन माझ्यासाठी बेस्ट असेल, तो पुढचे ऍक्शन एक्सप्लोर करणार नाही. फास्ट लर्नर मध्ये तो लेटेस्ट ऍक्शन कन्सिडर करेल, बाकीचे ऍक्शन बघणार नाही. सो यू वांट टू मेक अ बॅलन्स बिटवीन you know that the slow learner and fast learner. That's why the value of alpha will decide you how much the value you want, how much the information or the knowledge you want to override by the new information. म्हणजे या स्टेटला जी व्हॅल्यू मिळालेली ती रिप्लेस करायची की नाही नवीन इन्फॉर्मेशन नाही हे ठरवण्याचं काम कोण करतं? लर्निंग रेट. लर्निंग रेट विल डिसाइड कि the current state values you want to replace by new values or not. Sometimes it replace by new values, but that will not be the good. Sometimes it will not replace, but that will be also not good. Right? So learning rate will decide how much values they want to replace by the new values. Okay. So this is what the learning rate, and the equation is given. Value of current state is equal to value of state plus alpha, reward RT plus 1 plus gamma is discount factor, value of next state minus value of the present state. Value of ST plus 1 means what? The value for the next state, and value of ST means what? The value for the present state. The value of the present state will be replaced by the value of the next state. How it is calculated? Using the Bellman equation, and this Bellman equation is modified in the reinforcement learning algorithm. This is what important formula to calculate the value for each state. Next. Internet, right? So I can show you the cardboard demo.
वाईफाई आहे की इथे? नाही. जिओ ओपन
means, so it will decide ki, see the initial state is for example 1 1 and it started from 1 1 and for 1 1 it got the 3 rewards 10, 30 and 30. So it take the average of this. Okay, so 30 plus 30 plus 10, it takes the average it divided by 3 because 3 episodes are here and what are the values which are the state values. So for 1 1 the value is nothing but the average value of these 3 episodes. Next time the same state is there 1 1 and it is started through the different episodes and it got the values for an example 60 average value and this existing values is 50, then it will replace that 50 value by the 60 values. So in this way it will actually replace the values. I just want to show the see, here are two states we can see. Sometimes it retains in the same state, sometimes it goes into the next state. A to B, A to A or B to B. So what is the, if it is in state A, then what is probability to go into the state B? Okay, or what is probability of remaining the same state? If it is in the state B, what is probability that remaining in the same state or go to the next state, that is A. So based on the probability determined. So this is what the dynamic programming. But in reinforcement learning, based on the state values, it decides whether they want to stay in the same state or go to the next state. So this is what the difference between the dynamic programming. See, here is a rainy and sunny. So today is sunny, rainy, and based on that, you know that. So it takes the decision based on the current state only. What will be the next, sunny or rainy? Looking at this diagram, tell me which one is the shortest path. A is the initial state and F is a goal state. So which one is the shortest path? A to C and C to F. Right? So A to C is 15 and C to F is minus 200. Minus 200 plus 15 is equal to 185 minus 185. If we choose A to D and D to F, A to D is minus 20 and D to F minus 100, that is minus 120. But when we don't have the knowledge of D and A, we have the present state A. It is connecting to E, C and B, so and D. So out of that, A to D is the best path. Minus 20, right? A to D is the best path, right? Because it is a minimum distance, right? It is a minimum distance. We see the minimum distance. A to D is a minimum distance minus 20. So D to F is minus 100, but minus 120 is the best path? No. Actual best path is A to C and C to F. So sometimes in dynamic programming, it's turned into the local maxima. Local जे लोकल जी ॲक्शन आहे ती ॲक्शनच त्याला बेस्ट वाटायला लागते. ओके, सो इट चूज द D instead of C. So that's why it just explore randomly A to D. Next time it explore A to C. So here different path A to D F it is one policy, A to C F it is another policy, A to E F it is another policy, A to B, B to D, D to F it is another policy, and out of this it try to find out the optimal policy. Next. So I'll skip this part, transition properties and all. Okay, so I'll not go in detail. Next. I'll skip this. How the cumulative rewards will getting. I'll directly tell you the Q learning algorithms. Go next. Yes, Q algorithm. So in state action, state values that we get it, okay. But there is another important algorithm, Q learning. Why Q learning is important? Because in deep Q reinforcement learning, Q learning algorithm always used. So that's why Q learning or understanding Q algorithm is very important. So it considers the state mapping of state action values. State to action values it consider, and out of that best Q value will be considered for taking the action. So here the goal is that to find the sequential order of action which maximize the sum of future reinforcements that leading to the shortest path from start to finish. Next. Here is formula to calculate the Q values. It is very important. Only one formula is there to remember. The Q of state to action mapping is equal to reward of that particular state action plus gamma. Gamma is discount factor, the values in between 0 to 1 into maximum of Q of next state all actions. Means the maximum, all the states will be explored, and which state is having the maximum values, only that values is considered. Okay, so this is the formula to calculate the Q values. So many states are there, the Q value of max Q values of that particular state will be considered. Next. See, I will give a one problem statement. There are some doors, okay, and he has to reach at particular goal. Suppose we have 5 rooms in the building connected by doors. We will number is 0 through 4. The outside of the building can be thought as one of the big room number 5. The outside of the building, we notice the door 1, 4 leading to the building room number 5. Suppose we want to go to the room number 5, so through room number 1 we can go, through room number 4 we can reach to the room number 5. So this is all the building structure, and I want to reach to the room number 5. So we can this structure present into the matrix form. Okay, next. Or we can say that tree form. So all these rooms which are connected to each other, which are represented by the nodes. So room number 1 is connected to 5. Yes, it is shown 1 to 5 direction. Room number 1 is connected to 3. Yes, 1 to 3 connection is there. Room number 2 to 3 is connected. Yes, there is a connection between room number 2 and 3. Room number 4 to 3, yes, there is a connection 4 to 3 in between. Room number 4 and 5, there is a connection in between room number 4 and 5. Actually, there is a there is a direct connection 4 to 5, okay, externally. And room number 5 itself is a board state and it has a itself connection. And there is a connection between 0 to 4. See, there is no connection between 0 to 2. right? Because room number, if you are in the room number 0 and you want to go to the 2, you cannot directly go to the room number 2. There is no direct connection. That's why there is no direct connection between 0 to 2. The room number 2 ला पोहोचायचं, room number 0 पासून 2 ला जायचं असेल तर we will go first 4, then 3, then 2. So 0 to 4, 4 to 3, 3 to 2. Right? So this diagram will be represented in the form of graph. You understood? It's very simple, right? The graph is given, right? The nodes and we can say that vertex and edges which are given, edges represent the connection between them, direct connection. Indirect connection is not taken. So direct connection between them, right? To and from. Next. So 2 is the start state. As of that, 2 is the start state and 5 is the finish state. Okay. So we'll start from room number 2 and we want to reach room number 5. So how we will reach? So there are different ways to reach 5. We'll start from 2, 2 to 3, 3 to 1, 1 to 5. 2, 3, 1, 5, it is one path. 2, 3, 1, 5, it is one path. 2, 3, 4, 5, it is another path. Yes? जर आपण 2 पासून सुरुवात केली तर 2 पासून 3 ला जाऊ, 3 पासून 1, 1 पासून 5 ला. हा पहिला पाथ झाला. 2 पासून 3, 3 पासून 4, 4 पासून 5. हा सेकंड पाथ झाला. Now we want to find out which one is the best path. How? Using Q reinforcement learning algorithms. We can go from 2 to 3. Then at 3 there are two directions. Whether you want to go 3 to 0 or 3 to 4. So making best action at room number 3 is very very important. And Q reinforcement learning algorithm will tell you if you go to the 1 or 4, okay, based on the values, Q values. Okay. So this is what the representation. Here some values are introduced, 0 and 100. 0 means no remote, direct connection is there. 100 means you reach to the goal state, that's why 100. Because 1 from 1 it directly leads to the goal state, that's why 100 is given. From 4 to 5 direct goal state will be achieved, 100 is given. From 5 to 5 itself is a goal state, 100 is given. And all other are given 0 because they will not lead directly goal state. Right? म्हणजे 1 पासून 5 ला तुम्ही जाऊ शकता, 4 पासून 5 ला जाऊ शकता आणि 5 मध्येच 5 ला राहू शकता. 3 स्टेट असे आहेत की तुम्हाला 100 रिवॉर्ड्स मिळणार आहे, बाकी 0 आहे. So it is represented like this, state to action. There is a direct connection, reward is 0. There is no direct connection, reward is -1. And there is a goal state connection, reward is 100. So 0, -1, 100. State to action 1 reward matrix we want to prepare. म्हणजे बघा 0 स्टेट मधून 0 ला तो जाऊ शकतो का? नाही, तिथे स्टेट नाही दिलेली म्हणून -1. 0 पासून 1 ला जाऊ शकतो का? देयर इज नो डायरेक्ट कनेक्शन, -1. 0 to 2 नो कनेक्शन, -1. 0 to 3 नो कनेक्शन, -1. 0 to 4 yes there is a connection, 0 to 4, but there is a no goal state, that's why 0. And 0 to 5 no connection, -1. So you can see 5 to 5 connection is there, that is 100 is there. 1 to 5 is there, 100 is there. 4 to 5 is there, 100 is there. Back. Yes, you can see. 4 to 5, 100 is there. 1 to 5, 100 is there. And 5 to 5, 100 is there. 2 to 3, 0 is there. But 2 to 1 is -1 because there is no direct connection between 2 to 1. See, 2 to 1, -1. म्हणजे पहिले आपलं स्ट्रक्चर आलं, देन ग्राफ रिप्रेझेंट केला आणि त्या ग्राफ वरून वी ड्रॉ मॅट्रिक्स, रिवॉर्ड मॅट्रिक्स. आता हा मॅट्रिक्स चेंज होत राहील बेस्ड ऑन द क्यू व्हॅल्यूज. Okay. Using this formula, this is very important, and using this formula the value of Q will be changed. Yes. This is reward matrix, and first one is a Q matrix, state to state. Q matrix means from one state to next state, whatever the value is there, initially we don't know any information, Q's की value can assume it zero. Assume it zero. Reward matrix that we got it, reward matrix from the we defined earlier, but Q matrix we don't know, that's why we want to define as zero. And using such a formula, we want to put the gamma is equal to discount factor 0.8 and alpha learning rate, and the value is changed after 100, 500, 1000, 10,000 episodes, and you will get the final answer. So I have explained step by step what is value of Q 1 to 5. We put the values in the formula and you get the values. Next. Back. Yes. This is what the values we want of Q values 2 to 3, 51, 64, 3 to 1, and 3 to 4, 80, 64. Okay, these values that we got it. Right? These are the Q values, and this sequence is 2 to 3, 3 to 1, and 1 to 5. This is the best path that we have chosen. 2 to 3, yes, 64 is there. 3 to 1. We get 3 to 1, there is 80 is there, okay, and 1 to 5 is maximum values. So 2, 3, 1, 5, this is the best path using the Q reinforcement learning that we get it. Next. Actually, it is already implemented this using the collab. So you will find out it is open source. You just search it. Google it, okay, Q reinforcement learning, you will get it and you can find out the best. Yes. Giving me 15 minutes. No. Okay, so we are at the concluding session. So we have seen, so far we have seen from artificial intelligence evolution to the reinforcement learning algorithms, as it is started from the data with the machine learning algorithms, then without any data reinforcement learning algorithms, how it is used. When we are unknown about the environment and the data, then reinforcement learning algorithm is the best one. It just works based on the rewards itself. So how to define the rewards? So it is there are different ways to define the rewards based on the type of the environment, whether it is episodic or the continuous. One algorithm that we discuss dynamic programming, and second is Q learning algorithm. Here we consider both the values, action values as well as state values. But there is a limitation to these Q learning algorithms. It can work for 16 grade, 32 grade, or limited. It has the limited scopes. But when we have vast amount of the data, like image classification or the image perception and taking the action, like autonomous car is moving and there is a dynamic environment, then we perceive the information and taking the actions. It is too difficult to store this information in the table, because in Q learning table all this information we overwrite and store into the table, and based on that we take the action. But it is very difficult, there are so many obstacles, dynamic environment, number of vehicles, right, left, moving and all, speed and all. So it is very difficult to store into the table. If we talk about the chess game, it has 10,120 states, right? But still, you know that a table is impossible to store all the states and take the decision from it.
and in autonomous vehicles and in pixel reading, so image storing it is very difficult. So then deep learning came into the picture. So deep reinforcement learning, what it does, in Q learning we have seen we find out the Q value. In deep learning, deep neural network architecture is used to find out the Q values. This is simple architecture, as we know that state, the interaction between agent and the environment, and it gives the rewards. So we integrate the neural network architecture in between agent and the environment interaction. So what are the states which are given, okay, and that state will be provided as an input to the neural networks. Neural network has many layers, as we already learned in machine learning algorithms. I think there is a input layers, hidden layers, and output layers, right? So input layers will take the inputs as a states values, and through the hidden layers it will be processed, and output layer will give the maximum Q values, and based on the maximum Q values it will choose the best action. Okay, so here what are the Q values which are stored into the table, from that it will choose the action values. But in deep reinforcement learning, it uses the neural network architecture to find out the best Q values, and from that Q values it choose the best action. This is what the deep Q reinforcement learning algorithms. It is used by the Google, and it beat the humans at Atari games. Atari games, it is one of the games, and Google has used deep reinforcement learning, Q reinforcement learning, and that game has defeated the human in Atari games. There is a link. Yes, you can also search in Google key, yes, Atari games. So you'll find out that how to play it. We will move towards the almost last slide of this my session. Nowadays we are talking about the agent. In reinforcement learning also there is an agent, because agent always interact with the environment and choose the best action. ChatGPT is also agent, right? We are performing the different tasks with the help of different agents. So if there is if we require the more than one agent to perform the more than one task, it is called as the multi-agent reinforcement learning. MARL, multi-agent reinforcement learning. So each agent independently learns. Each agent independently learns and perform the task. ये एजेंट प्लानिंग का काम कर रहा है, ओके, इट विल लर्न कि हाउ टू मेक अ प्लान. ये एजेंट इंफॉर्मेशन रिट्राइव का काम कर रहा है, सो इट विल वर्क इंडिपेंडेंटली. ये एजेंट कैलकुलेशन का काम कर रहा है, इट विल लर्न इंडिपेंडेंटली एंड कैलकुलेटिंग. सो प्लानिंग, you know that planning, then calculating, then whatever the decision taking. So each agent will take the decision. Whatever to make a plan like that. You just ask to the ChatGPT to make a plan for 2 days plan for this for the trip of Konkan or the Goa. So it will do the plan. So one agent will working, right? Yes, you will ask yes, make a plan as well as also give me a cheap rate flight tickets. So another agent will work on the finding the cheap rate flights, right? You can ask yes, also find out the cheap rate hotels to stay there. Okay. So another agent will start to work on it. Yes, which are the cheap rate hotels. So cheap rate flights, cheap rate hotels, and planning, making a plan for the 2 days. So 3 agents simultaneously working on it, but they are independently learning and giving the reply to you, right? This is what the multi-agent reinforcement learning. It is called as the independent Q learning. Another type of Q learning is cooperative multi-agent reinforcement learning. Means to perform one single task, 2 agents simultaneously working on it, they are cooperating to each other and performing the task. That is cooperative reinforcement learning. Where it will work? Like in football, there is a one team, there is another team. ये मेरे टीम का है तो हम दोनों मिलके काम करेंगे, मल्टीपल एजेंट्स, और तू मुझे कॉपरेट करो, मैं तुझे कॉपरेट करता हूँ, एंड वी वांट टू रीच टू द गोल, और वी वांट टू सेट द गोल, राइट? दिस इज व्हाट द कोऑपरेटिव मींस. मल्टीपल एजेंट्स, they work together to achieve the goal. This is what cooperative. And competitive reinforcement learning, multi-agent reinforcement learning means what? Multiple agents works against each other for a competitions, right? कि मुझे भी कंपटीशन करनी है, आपको भी कंपटीशन करनी है, तो मैं मेरे हिसाब से ट्राई करता हूँ, आप आपके हिसाब से ट्राई कर रहे हो, कौन जल्दी पहुँचता है. This is what the competitive multi-agent reinforcement learning. So these are the different types of the reinforcement learning. As initially we have seen the dynamic programming, then Q learning, reinforcement learning. It is the very best. There are many types. Actor critic is also there, but actor critic is having a different types, and it is not easy to cover in one session. Okay. And Q learning, yes, we have explored the deep Q reinforcement learning and different types of the multi-agent reinforcement learning. So these are the different applications. I think the slide is not visible, but it is used in many areas. Autonomous vehicle is there, robotics is there, game playing is there, then in financial planning is there, in stock market is there, right? So there are so many applications where it will be used. Thank you. This is from my side. I hope you enjoyed the session. If you have any query, any doubt, any questions regarding the machine learning, reinforcement learning, yes, you may ask. I'll be happy to answer you. Any questions which are related to your the FDPs? Yes. What is the difference between agent and agentic AI? आम्ही टीचरला टीचरने क्वेश्चन विचारलं तर मुलं काय उत्तर देत नाही, मग टीचरलाच क्वेश्चन करावा. एजंट and agentic AI. Agent is single agent, agentic AI is the multiple agents. Just name is different. In the computer engineering, in the we can say that in our CS field, we are saying that nowadays AI is used everywhere, in education, in medical science, everywhere we can use the AI, artificial intelligence. But if we talk about the AI, the concept of AI is getting introduced in 1950. 1950 मध्ये AI ची concept introduce झाली. At that time, slowly it is explored, and the infrastructure was not there. Right now 5G is there, and when we export to the 6G, 6th generation, आता 5G आहे तरी आपल्याला जिओचं नेटवर्क नाही मिळालं, ती वेगळी गोष्ट आहे. 5G जिथं नेटवर्क आहे 5G च्या स्पीड मध्ये you are able to watch the live streaming videos and all. In 4G it was not there. Hotstar and all, everything that you can easily watch. In 5G the speed is up to 1 Gbps. When 6G will be exported, the 100 Gbps speed will be there, and you can easily connect to any simulation environments. Aging AI will be there, 6G will be there. The cameras which are assembled here just capture the information but not able to take the decision. So in future you will find out that the capture has the ability to take the action. For an example, if any student is misbehaving in the class, immediately the camera at the same time will tell you yes, you are not doing good. Okay, that is edge computing, means able to take the decision itself at the device. Right now what we are doing, we capture the frames, we capture the images, and we do it, process it using machine learning algorithms and take the decision. But in 6G, it will be connected directly to the cloud. All images, real-time images will be shared with cloud, and on cloud, machine learning algorithm processed online, on time, okay, real time, and immediately give the solutions, immediately give the answer. In 6G communication itself has the ability to sense the everything. Means there will not require any sensors in the future. The antennas, we know that the towers which are installed for the networking or for transferring the call and the voice and the audio video information, right? So these towers itself, it will have the capacity to sense the things, okay, and will able to take the decision. It will be helpful for the smart cities. They will easily capture the information how many vehicles on that particular road, and they will assist to the driver. You can divert, there is a traffic. There is no need to install the cameras on the roads to capture the vehicles images, and based on that image vehicles, number of vehicles are there, and take the decision whether there is a crowd or not. Now it will count the vehicles, right? So based on that it tell you if there is the rush or not, right? But it will be, that will be dissolved, and the network, the tower will capture such as information through the satellite, and that will assist to the driver whether which route you want to take, right? So that will be the future of artificial intelligence. Thank you very much.
Thank you, sir. Good afternoon, everyone. As we have come to the end of the session, it is my proud privilege to propose a vote of thanks. So, thank you, sir, for everything you have taught here. First and foremost, we provide a sincere gratitude to the Aicte and the Atal Academy for providing us this with the wonderful platform, and for providing the technical and competence between all the faculty members for their support here. I thankful or provide deep thankful to our esteemed resource person, Dr. Svcet sir. Thank you, sir, for your clear explanations about the core concept about the machine learning and also artificial intelligence. You have covered each and everything in a very clearly manner. So thank you for your presence here as we get a deep knowledge about each and every core concept that you have provided here. Thank you all the participants for your presence here. So thank you, sir.
वर चालू ठेवतो.